question 9 talks about installing the fiber optic cables into an HDB unit, and it talks about how quickly that can happen. So this company called Open Network claims that they can install the fiber optic cables within mu0 minutes, so in time less than or equal to mu0. And online critics are saying that no, that's not true. So they take a sample of 12 independent observations of how long it takes. The mean and the standard deviation of these sample times were found to be 21.3 and 4.5 minutes respectively. A test is carried out at 2.5% significance level to determine the refutation of the online critics. State the appropriate hypotheses for this test. So, what are we testing? Well, we're going to test the claim of our dearest company, H0, that the mean, the true mean, is actually equal to mu0, whatever they've claimed mu0 to be. This also includes the case where it's less than mu0, because I'm testing it against our online critics' claim that the mean is actually greater than mu0, that they cannot get it done within mu0 minutes. So part 2 asks us to explain in the context of the question the meaning of at the 2.5 significance level. What does that mean? It means that there is a probability of 0.025 that the test concludes the mean time to install the cables, the fiber optic cables, is more than mu0 minutes when in fact it is not. It is not. So the key thing here is this is the probability that the test concludes that the mean time is more than mu0 minutes, when in truth it is not. So it's a statement about the probability of the conclusion of the test. In other words, it can tell us how likely this test is to wrongly reject H0. And that's the other way of thinking about this. This is the probability of incorrectly rejecting H0 given that H0 is true, right? Okay, so part 3. Suppose the test yields a result that does not reject the null hypothesis. Find the set of possible values of mu0. State any assumptions that you have made. Okay, so to do this, I need to know my values of x bar and s squared. Well, x bar is easy enough because they tell me that the sample mean is 21.3 minutes, so that's also going to be my unbiased estimator. What about s squared? Well, remember, s squared, there's a formula for it which is s squared is equal to n over n minus 1 times the sample variance squared, so sigma s squared. So this is just going to be, we had a sample of 12, that means it's 12 divided by 11 times, and the variance is of course just the standard deviation squared. So this number is approximately equal to hold on a second. So this number is approximately equal to 22.091. Okay, so what does that mean? Well, we've got this. So under H0, assuming H0 is true, what do we have? Well, our test statistic T will be x bar minus mu0 over s over root n. Okay, seems fair enough. So, and this will of course follow a t distribution with n minus 1 degrees of freedom, so 11 degrees of freedom. So what does that mean? Well, if it's not rejected, it means that if I looked at my distribution, remember a t distribution kind of looks like a normal distribution. It's just a bit fatter, I think. So this would be my critical region here. where this has an area of 0.025, right? Because that was my level of significance. So what is the value of t calculated here? Oh, not t calculated, sorry, but what's the value of t along this critical region? So to find that, I should go to my GC, and I should go to my inverse t, number 4 here. And remember, the area always counts from the left. So if this area is 0.025, I actually want 0.975 to be my area. And I've got 11 degrees of freedom because there are 12 items in the sample. This means that my inverse t is going to be 2.200, 2.201. So this is 2.201. Fantastic. Well, what is my t calculated? My t calculated is what I get when I substitute in x bar into this equation. So I want to find out what is t calc, and this will be 21.3 minus mu naught over s over root n. So this is the square root of, remember, s is actually the square root of this number. S squared is 22.09. So this is square root of 22.09, 1 divided by n, which is 12. So we get this horrible looking number on the bottom, but that's okay. We can do something with that. So this is 21.3 minus mu naught over 1.3568. Okay, so if h naught not rejected, what does that mean? That means that my t calculated value mustn't be in this critical region here. In other words, t calculated has to be less than or equal to 2.201. So in other words, 21.3 minus mu naught over 1.3568 must be less than or equal to 2.201. So in other words, 21 minus mu naught, 21.3 minus mu naught must be less than or equal to 2.201 times 1.3568. In other words, mu naught needs to be greater than or equal to 18.31370. So mu naught should be greater than or equal to 18.4, rounding to 3SF. And you notice that I've rounded up so that I'm inside the region. Okay? Okay, cool. Now there's one assumption that I needed to make to use a t distribution, of course, and that is when I've got a t distribution, I need to assume that my data x is normally distributed. It will not work otherwise. Okay. So part 4. Okay. But there is one thing I should be careful of. Oh no, it actually defines x for me. Okay, cool. Part 4. Given instead that the standard deviation of x is 5 minutes and that mu naught is 19, find the least significant significance level at which the null hypothesis is rejected. So this is a whole new kettle of fish now. Why is this a new kettle of fish? Because I'm actually given the standard deviation of x. So that is, I know x, which is my continuous random variable denoting the time in minutes spent by the technician of the open network, is normally distributed. So I can assume that now, I think. No, I can't. I don't know it's normally distributed. But I do have the variance. So I do know now that sigma is equal to 5 minutes, and that mu naught equals to 19. So this is part 4. So what am I going to do? I still have, of course, x bar equal to 21.3 and n equal to 12. But now it's slightly different. Why? Because under h naught, now that I know the I know the population variance, I can instead use a z-test instead of a t-test. So z is equal to x bar minus mu naught over sigma over root n. So this time this is going to be x bar minus 19 over sigma, which is 5 over square root 12. Okay, and this is of course going to be a normal 0, 1 distribution. And I'm asked to find the least significance level at which the null hypothesis is rejected. So if we test this, so from GC, what do we find? So let's go to our GC. Hope this works. And I'm going to go to stat. This time I'm going to go to test, a z-test. I'm going to input by statistics. My mu naught is 19. My standard deviation for my population is 5. My value of x bar is 21.3. My value of n is 12. And I'm testing that mu is greater than mu naught. So when I calculate that, what do I get? I get a p-value of 0.05555255, right? So my p-value is equal to 0.0555255. What does that mean? Well, it means that if I had my distribution out like this is z, of course, and I can draw my normal distribution in, that the chance of getting a result like this, just, by circumstance, this isn't the critical region, this is the p-value, 0.0555. So there's a 5.55% chance, give or take, of something like this happening, just by luck. So if it's to be rejected, so if h naught is rejected, we would need the level of significance to be bigger than the p-value. So we're asked the level of significance at which it is rejected, so we can say that alpha over 100, so alpha percent is what we're going to be talking about, must be bigger than 0.0555. In other words, that alpha has to be bigger than 5.552. So the least level of significance for which h naught is rejected is 5.56%.